Hi, I would like to ask you some questions. The first, tell me about yourself.
I am a full-stack developer with 5 years of experience. In the first 2 years of my career, I worked as a front-end developer, primarily focusing on React.js. However, my passion has always been in back-end development and cloud architecture, which led me to transition into back-end development with ASP.NET Core. Over the past few years, I have gained extensive experience in building microservices, working with cloud platforms like Azure, and implementing scalable, secure systems. I enjoy solving complex technical challenges, optimizing system performance, and working with distributed architectures. I am now looking for an opportunity to apply my expertise in a more challenging environment, particularly in designing and developing large-scale distributed systems while continuing to grow in cloud-native development.
Why do you want to work for our company?
I am excited about the opportunity to join your company because of its strong focus on building scalable and innovative software solutions. I have always been interested in working with complex distributed systems and cloud-native applications, and I see that your company heavily utilizes .NET Core, microservices, and cloud technologies like Azure and Kubernetes, which align perfectly with my expertise and interests. Additionally, I appreciate your company's commitment to engineering best practices, including domain-driven design, DDD, event-driven architecture, and CI/CD pipelines, as these are areas where I have hands-on experience and where I can contribute effectively. Beyond the technology, I am also drawn to your collaborative and agile work culture. I enjoy working in cross-functional teams where I can not only bring my skills in back-end development, but also learn from talented engineers and grow as a developer. I believe this role would be a great fit for both my technical growth and my long-term career aspirations.
What are your greatest strengths as a developer?
One of my greatest strengths is that I am a detail-oriented and meticulous developer. I always strive to write clean, maintainable, and well-structured code, ensuring that the systems I build are both reliable and scalable. Additionally, I am a hardworking and proactive team member. I take ownership of my tasks, continuously improve my skills, and stay updated with new technologies to deliver the best solutions. Another key strength is my problem-solving ability. Whether it's troubleshooting system performance, debugging complex issues in microservices, or optimizing cloud-based solutions, I always take a structured approach to analyze and resolve challenges effectively. Finally, I am highly collaborative and enjoy working in agile teams. I believe that strong communication and teamwork are essential for delivering high-quality software, and I always strive to contribute positively to the team environment.
What is your weakness?
One of my weaknesses is my ability to express my ideas and present my viewpoints in front of a large audience. Sometimes, I feel nervous when speaking in front of many people, which can make it difficult to articulate my thoughts clearly and effectively. However, I am actively working on improving this skill. I have started practicing more by speaking up in team meetings, preparing my points in advance, and learning techniques to stay calm under pressure. Over time, I have seen progress, and I am confident that with continuous effort, I will become more comfortable and effective in public speaking.
What is a challenge you faced in a project, and how did you overcome it?
During my time at my company, I had the opportunity to work in an extreme programming (XP) team. This development methodology emphasizes fast iterations, continuous feedback, and high-quality code delivery. Working in an XP environment was both challenging and rewarding, as it required the team to be highly focused, adaptable, and efficient in delivering software solutions. One of the most challenging situations we faced was when we had to implement a new feature under a very tight deadline. At that time, even our business analyst, BA, and back-office teams were not completely clear on the requirements, making development even more difficult. However, we needed to release the feature as quickly as possible so that the back-office team, BA, and stakeholders could test it in a sandbox environment, gain a better understanding, and refine the requirements based on real usage. This approach required high concentration and strong collaboration from the entire team. However, once we overcame these challenges, it significantly accelerated our learning and helped us adapt quickly to requirement changes.
Where do you see yourself in 5 years?
In the next 5 years, I see myself growing into a technical leadership role, such as a senior .NET developer, software architect, or technical lead. My goal is to deepen my expertise in distributed systems, cloud-native development, and performance optimization, ensuring that I can design and build highly scalable, maintainable, and efficient applications. I also want to continue expanding my knowledge in cloud computing, particularly with Azure services, Kubernetes, and event-driven architectures, to create robust and high-performance systems.
Why are you leaving your current job?
I have really enjoyed my time at my company, where I have gained valuable experience working with .NET Core, microservices, cloud technologies, Azure, Kubernetes, and extreme programming. The projects I have worked on have helped me develop strong problem-solving skills and a deep understanding of distributed systems and scalable architecture. However, at this point in my career, I am looking for new challenges and opportunities to grow further. I want to work on larger-scale distributed systems, explore more advanced cloud-native architectures, and take on greater technical responsibilities. Additionally, I am seeking a company where I can continue learning, contribute my expertise, and collaborate with talented engineers to build innovative solutions. I believe that your company provides the right environment for me to apply my skills, tackle more complex challenges, and advance my career while contributing to impactful projects.
How do you handle tight deadlines and high-pressure situations?
In high-pressure situations and tight deadlines, I focus on staying organized, prioritizing tasks, and maintaining clear communication with the team. First, I break down the work into smaller, manageable tasks and identify the critical areas that need immediate attention. This helps me stay focused and ensure that the most important features or fixes are completed first. Second, I believe in collaboration and transparency. If the deadline is challenging, I proactively discuss with the team and stakeholders to set realistic expectations, optimize the workflow, and explore potential trade-offs. Lastly, I stay calm under pressure and focus on solutions rather than problems. By approaching challenges with a structured mindset, I can deliver high-quality code efficiently, even under tight deadlines.
How do you keep up with new technologies and trends in software development?
As a software developer, I understand that technology is constantly evolving, and staying up to date is essential for growth. I have a structured approach to continuously learning and keeping myself updated with industry trends. Reading tech blogs and official documentation, I regularly follow https://www.thereformedprogrammer.net from John P. Smith to stay informed about new features, best practices, especially in EF Core, online courses, and hands-on practice. I take online courses on Pluralsight, Udemy, Coursera, and Microsoft Learn to strengthen my skills in .NET Core, cloud computing, Azure/Kubernetes, and software architecture. I also practice by working on personal projects and open-source contributions, joining tech communities and networking. I engage with tech communities on GitHub, Stack Overflow, and LinkedIn, where I participate in discussions, solve problems, and learn from other developers. Additionally, I attend meetups, webinars, and conferences when possible.
Have you ever had a conflict with a teammate? How did you resolve it?
Yes, conflicts can happen in any team, and I believe that how we handle them is what truly matters. One situation I encountered was during a project where we had a tight deadline to implement a new feature. I was working closely with another developer, and we had different opinions on the best approach to design a microservice. My teammate preferred a monolithic-style implementation for faster delivery, while I believed that following a proper microservices approach with clear bounded contexts would be more scalable in the long run. To resolve the conflict, I took the following approach. Stayed professional and open-minded. Instead of turning it into an argument, I listened to my teammate's reasoning carefully and acknowledged his concerns. After listening to my colleague's opinion, I will present my own solution, explaining its advantages and disadvantages, as well as the reasons why I choose to apply it. Of course, we will discuss together to find the best possible solution for the problem. In the end, everyone in the team needs to reach an agreement before making the final decision.
Can you describe a time when you received constructive criticism? How did you react?
I remember a recent time when I was assigned to develop a webhook processing feature as part of our integration with a major bank. The deadline was tight, only 2 days, so I had to quickly go through their documentation to implement the feature as efficiently as possible. When my team lead reviewed my work, he provided some constructive feedback, pointing out that I needed to snapshot all incoming webhooks before our system processed them to ensure data integrity. I quickly applied his suggestion, adjusting my implementation accordingly. Not only did this help me deliver the task on time, but it also gave me valuable real-world experience in handling webhook processing more effectively. This experience reinforced my belief that we should always be open to feedback and learning from our colleagues, as it helps us grow and improve as developers.
What are the key differences between .NET Core and .NET Framework?
There are several key differences between .NET Core and .NET Framework, primarily in terms of cross-platform support, performance, and modularity. First, cross-platform compatibility. .NET Core is cross-platform, meaning it runs on Windows, Linux, and Mac OS, while .NET Framework only works on Windows. This makes .NET Core a better choice for modern cloud-based and containerized applications. Second, performance and scalability. .NET Core is faster and more lightweight compared to .NET Framework, especially in web applications and microservices. It provides better performance due to improved just-in-time, JIT, compilation, and asynchronous programming. Third, modularity and flexibility. .NET Core follows a modular approach with NuGet packages, allowing developers to include only the necessary dependencies, reducing the application size. .NET Framework, on the other hand, is monolithic, meaning it comes with all built-in libraries, even if you don't need them. Fourth, deployment model. .NET Core allows self-contained deployments, meaning you can package your application along with the .NET runtime, making it independent of the system's installed framework version. .NET Framework requires the correct framework version to be installed on the system before deployment. Microservices and cloud support. .NET Core is optimized for microservices architecture and works seamlessly with Docker, Kubernetes, and cloud platforms like Azure. .NET Framework is less suitable for microservices and cloud-native development. Fifth, future and support. .NET Core has evolved into .NET 5, .NET 6, and beyond, which are now unified under the new .NET platform. .NET Framework is no longer actively developed except for security patches, meaning new applications should be built using .NET Core.
Can you explain how you apply domain-driven design, DDD, in your projects?
In my projects, especially when working with microservices and complex business logic, I apply domain-driven design, DDD, to create a well-structured and maintainable system. Here's how I integrate DDD into my development process. Understanding the domain and ubiquitous language. Before designing the system, I collaborate with business analysts, BAs, product owners, and domain experts to understand the core business rules. We define a ubiquitous language, ensuring that both technical and non-technical stakeholders use the same terminology to describe the business domain. Defining bounded contexts. I break down the system into multiple bounded contexts, each representing a well-defined part of the domain. For example, in a fintech application, we might have separate contexts like payments, transactions, and user management. This separation helps avoid dependencies between unrelated parts of the system, making the architecture more scalable and maintainable. Implementing aggregates and entities. I define aggregates as the primary building blocks of my domain model, ensuring that business logic is encapsulated properly. Aggregates enforce consistency within their boundaries, preventing direct manipulation of internal entities from outside. Example: in a payment context, an invoice aggregate might contain multiple invoice items, and all modifications should go through the aggregate route. Using domain events and event-driven architecture. Instead of relying on direct database updates, I use domain events to decouple components. For example, when a payment is completed, an event like payment completed event is published, triggering actions in other microservices, e.g., sending notifications or updating reports. This improves system scalability, flexibility, and maintainability. Applying repositories and unit of work patterns. I use the repository pattern to abstract data access and keep my domain logic independent of the database. The unit of work pattern ensures that changes are committed as a single transaction, improving consistency. Leveraging CQRS, Command Query Responsibility Segregation. For read-heavy applications, I sometimes apply CQRS to separate write operations, commands, from read operations, queries. This improves performance and enables event sourcing if needed. Example of DDD in a fintech microservice. Bounded context, payments, aggregate route, entity. domain event, repository, service layer. By following DDD principles, I ensure that the system is scalable, maintainable, and aligned with real-world business logic. It also helps in microservices-based architectures by defining clear service boundaries and minimizing dependencies between services.
What are microservices, and how do they differ from monolithic architectures?
Microservices are a software architecture pattern where an application is broken down into small, independent services, each responsible for a specific business function. These services communicate with each other using APIs, usually via REST, gRPC, or message brokers like Azure Service Bus. In contrast, a monolithic architecture is where the entire application is built as a single, tightly coupled unit. All components, UI, business logic, and database access, exist within the same codebase and are deployed together. While monolithic architecture can be simpler to start with, microservices provide greater scalability, flexibility, and fault tolerance, making them the preferred choice for modern, distributed, and cloud-based applications.
What is Identity Server for, and how does it help with authentication and authorization?
Identity Server 4 is an open-source authentication and authorization framework built on .NET Core. It is used to secure applications by implementing OpenID Connect, OIDC, and OAuth 2.0 standards. Identity Server 4 allows applications to manage user authentication, issue security tokens, and handle access control in a secure and scalable way. How Identity Server 4 helps with authentication and authorization. Authentication. Who are you? Identity Server 4 acts as an identity provider, IDP, verifying user credentials and issuing identity tokens. It supports single sign-on, SSO, allowing users to authenticate once and access multiple applications securely. Example: when a user logs into a fintech system, Identity Server 4 authenticates them and issues a token that grants access to different services. Authorization. What can you do? It uses OAuth 2.0 to issue access tokens, determining what resources the user or application can access. It supports role-based access control, RBAC, and policy-based authorization to define user permissions. Example: a customer service representative might have access to user data, but only an admin can modify payment settings.
How do you optimize the performance of a .NET Core application?
Optimizing the performance of a .NET Core application requires focusing on several key areas, including efficient database access, proper memory management, asynchronous programming, caching, and profiling tools. Here are some best practices I follow to ensure high performance in my applications. Optimize database queries. Use asynchronous queries, async/await, to avoid blocking threads. Apply pagination when retrieving large datasets to reduce memory usage. Optimize indexes in SQL Server and avoid unnecessary joins. Use Entity Framework cores. As no tracking when queries don't require change tracking. Implement caching. Use in-memory caching, iMemory cache, for frequently accessed data. Use distributed caching, e.g., Redis, in microservices and cloud-based applications. Use asynchronous programming. Avoid blocking operations by using async/await. Use iasync enumerable t to process large datasets efficiently. Reduce memory allocation and improve garbage collection. Use structs instead of classes for small immutable objects to reduce GC pressure. Reuse HTTP client instances instead of creating new ones for each request. Optimize logging and monitoring. Use structured logging with tools like Serilog, Seek, or Application Insights. Minimize unnecessary logging in production to avoid performance overhead.
What is dependency injection, and why is it important in .NET Core?
Dependency injection, DI, is a design pattern that allows us to inject dependencies, services, repositories, etc., into a class instead of creating them inside the class. It helps in achieving loose coupling, improving code maintainability, and making unit testing easier. In .NET Core, DI is built into the framework, allowing us to register services in the dependency injection container and inject them wherever needed. First, why is dependency injection important? Loose coupling reduces direct dependencies between components, making the system more modular. Improves testability, makes it easier to mock dependencies for unit testing. Enhances maintainability. Changes in one class don't require modifying dependent classes. Follows solid principles, specifically, the dependency inversion principle, DIN solid. Second, how dependency injection works in .NET Core. Step 1. Register dependencies in the DI container, program.cs. Step 2. Inject dependencies into the constructor. Dependency injection is a core feature of .NET Core that helps in writing scalable, maintainable, and testable applications. By using DI properly, we can follow best practices in software design and create a more flexible and efficient system.
How do you handle logging and monitoring in a cloud-based microservices system?
In a cloud-based microservices system running on Azure Kubernetes Service, AKS, I use iLogger for structured logging and integrate it with Azure Application Insights for centralized monitoring. This setup helps in troubleshooting issues, analyzing performance, and tracking system behavior efficiently. Configure logging with iLogger. Configure Application Insights on Azure.